Space and time are not separate entities. They are intertwined, forming a unified fabric known as space-time. Imagine a trampoline, representing space-time. Placing a ball on it creates a dip, much like objects with mass warp the fabric of space-time. This warping is what we experience as gravity. Albert Einstein's theory of relativity revolutionized our understanding of gravity. It describes gravity not as a force but as a curvature in space-time caused by mass and energy. Objects move along these curves, explaining the orbital motion of planets around stars. Einstein's equations suggest the possibility of manipulating space-time to achieve faster-than-light travel. By creating a warp bubble around a spacecraft, we could potentially distort space-time, shortening the distance between 2 points and allowing for travel at incredible speeds. This concept, while theoretically possible, faces significant technological and energy challenges. However, the pursuit of understanding and potentially harnessing the power of space-time continues to captivate scientists and fuel our dreams of reaching distant stars. Imagine a surfer riding a wave, effortlessly gliding across the ocean. This is the basic idea behind the concept of a warp drive. Just as a surfer harnesses the power of a wave, a warp drive would utilize the fabric of space-time itself for propulsion. Instead of propelling the spacecraft through space, a warp drive would create a warp bubble around it. This bubble would compress the space-time in front of the spacecraft while expanding it behind, effectively creating a wave that the spacecraft would ride. This manipulation of space-time would allow the spacecraft to travel faster than the speed of light without actually violating any laws of physics. This is because within the warp bubble, the spacecraft would remain stationary relative to its local space-time. While this concept might sound like pure science fiction, it has captured the imagination of physicists and engineers alike. Research into the theoretical feasibility of warp drives is ongoing, though the technological hurdles to overcome remain immense. The idea of bending space-time might seem like something out of a science fiction novel, but it's rooted in real scientific principles. Einstein's theory of general relativity provides the framework for understanding how this might be possible. According to general relativity, mass and energy warp the fabric of space-time. The greater the mass or energy, the greater the curvature. This curvature is what we experience as gravity. To create a warp drive, we would need to find a way to manipulate this curvature. One hypothetical solution involves a substance called exotic matter, which is thought to possess negative mass-energy density. This exotic matter, if it exists, could create a repulsive gravitational effect, effectively pushing space-time apart. While the existence of exotic matter remains purely theoretical, its potential applications in bending space-time have fueled considerable scientific interest. If we could harness the power of exotic matter, it could revolutionize space travel and open up new frontiers in our exploration of the universe. Section 4. Other paths to the stars. Wormholes and beyond. Warp drives aren't the only theoretical concept for achieving faster-than-light travel. Another intriguing possibility lies in the realm of wormholes, cosmic shortcuts that could connect distant points in space-time. Imagine folding a piece of paper in half and poking a hole through it. The hole represents a wormhole, a shortcut between two distant points on the paper, which represents space-time. By traveling through a wormhole, a spacecraft could potentially cover vast cosmic distances in a much shorter time than traveling through conventional space. However, like warp drives, wormholes remain highly theoretical. Their existence has not been confirmed, and even if they do exist, the technological challenges of creating and navigating them would be immense. Despite these challenges, the search for alternative methods of faster-than-light travel, such as wormholes, continues. These concepts push the boundaries of our current understanding of the universe and inspire us to dream of a future where interstellar travel might be possible. Section 5. Reaching for the stars. The promise and perils of warp drive. The concept of warp drive, while still firmly in the realm of science fiction, holds immense potential for the future of space exploration. If we could overcome the significant technological challenges, warp drive technology could revolutionize our understanding of the universe and our place within it. With warp drive, we could travel to distant stars and galaxies, explore new worlds, and unlock the secrets of the cosmos. We could potentially even encounter other intelligent life, forever changing our perspective on humanity's place in the universe. However, the potential of warp drive comes with significant ethical and existential considerations. The ability to travel vast distances at incredible speeds raises questions about our responsibility to the universe and the potential impact on other civilizations. The pursuit of warp drive technology must be tempered with caution and a deep understanding of its potential consequences. As we reach for the stars, we must do so responsibly, ensuring that our quest for knowledge and exploration does not come at the cost of the universe we seek to understand.